Good afternoon. Welcome to TU Delft. Welcome to 3ME. And obviously also welcome for all of you 20-some people watching online. Today is a big day for Willem.
Yes.
Final part of his master program. Today he's going to tell us a little bit more about his master thesis, but before we do that, let me very briefly introduce the committee. We have Jaap Hala, who's a professor at the biomechanical department here at the faculty. Tom van Reet, who was one of the supervisors from the Amsterdam UMC. Osama Mazar, who's a postdoc in the cognitive robotics department. And my name is Jens Kober. I'm an associate professor also at the cognitive robotics department, and I was also one of the supervisors of Willem. As far as I understood, Willem already told you pretty much what's going to happen today. So now we have a presentation of 25 minutes, something along those lines. And please already think about questions for Willem on the presentation while he's presenting. For you present here, obviously you can ask live. And for the people following online, you'll have to put that in the YouTube chat. So, floor is yours.
Yes. Thank you for the introduction, Jens. A special welcome to the members of the committee and the people watching on the live stream. Today I will tell you something about understanding tooth removal. And to start, you should picture yourself as a dental student. And this is your view. And with only minor textbook instructions, you have to extract the tooth. You have no clue what you have to do, because there was no possibility to train this on forehand. So, this is a problem. And these problems are that we don't have scientific understanding of tooth removal, and there's no adequate preclinical training possibilities to practice the procedure on forehand. So, what I'm going to tell today is my attempt to answer or to solve this problem, which is happening in tooth removal. And that is understanding the tooth removal process. And if we have understanding of this process, we can improve education, so we can make adequate preclinical training possibilities, but we can also improve healthcare, because we will make sure that no unnecessary treatments are made. So these clinical consequences lead to my research question: how can the process of tooth removal be understood in terms of forces, torques, and movements? And we believe that with forces, torques, and movements, we will obtain all the parameters for measuring tooth removal. So as an outline for today's presentation, we will use the measure part, we will use an analysis part, and we'll use an evaluation part. And you can see these parts on the left bar to guide you through the presentation, so you know where you are, or you know where I am. So first, we measure the procedure of tooth removal. We need data to gain some understanding. And after we obtain this data, we will employ feature engineering to translate the data into a representation of features. And these features, we can use these features in a prediction model. And with this prediction model, we are able to make predictions and find patterns in the data. And the prediction model and finding these patterns are the last phase, which is the evaluation phase. So, first, to start, we are starting with the measure phase. And in this measure phase, we developed a measurement setup. And this measurement setup was able to measure the forces, the torques, and the movements made in tooth removal. And this is a video showing what happens during a measurement. And you see the dentist in green extracting a tooth from a cadaver jaw, which is mounted on a jaw holder. And what these components are doing, I will explain that in a minute. So you saw that the dentist extracted the tooth successfully. And these are the components of the setup. So we have a collaborative robot arm, a KUKA, and this KUKA is not autonomously extracting a tooth. This robot is only measuring the procedure of movement. So when a dentist is grabbing the forceps, which is mounted on the end effector, he can freely move the robot around. And when he moves this robot around, he is extracting a tooth from the holding device, and this holding device is made such that we can fit upper and lower jaws 100% rigidly. And underneath this holding device, we mounted a force torque sensor, which is able to measure the procedure measure the applied forces and torques when the dentist is making a movement. So we performed 150 measurements in total, of which 3 surgeons extracted teeth and 1 student extracted teeth. And we included this student to provide a complete overview of what happens and what the current state of dentistry of tooth removal is. So with the inclusion of this student, we can compare what the strategy or what the movements of the surgeons are with what the student is doing. And we had a main surgeon, we call it a main surgeon for the rest of the presentation, which was a very skilled dentist, and he had 68 successful demonstrations. And on the lower right, you see 2 figures of the gel holders we developed, and I mentioned it earlier. These gel holders ensure 100% rigid fixation of the fresh frozen cadaver jaws. For here I will show you 2 videos what measurements are we performed. So the first video is a video of the removal of an upper incisor, and the removal of this upper incisor is going with a certain strategy. And this is another video of removal of a molar tooth. And what you can see is that the extraction strategy is very different. And these differences look like this in the data. And we can see the differences, but we need to find out if these differences are coincidence or if these differences are a pattern appearing more often in the data. So that's what we are going to do with the analysis phase. So in the analysis phase, we use feature engineering to make a lower dimensional representation of the curves you saw before. And to make sure everybody knows or understands what I mean with feature engineering, I will give an example of a feature called direction changes. And the direction changes in the removal of an upper incisor is shown here in this figure. And what you can see is that the curve, the most important rotation curve, has 10 direction changes. If we compare it with the extraction of a molar tooth, we can see that the molar tooth has only 5 direction changes. So these are different representations of, this is the same representation holding different numbers for 2 different extractions. For my results of this feature engineering algorithm, I had to analyze the force features, the torque features, and the rotation features. And I will only present the rotation features here because they were most descriptive. I analyzed force features as well. They were found to be a little bit descriptive, and I did not use torque features because they did not hold very good accuracy later on the process. So I will focus on rotation features only. And what we saw with the rotation features is that the rotation in Y direction and the rotation in Z direction were most important when analyzing or when finding features. And the rotation around Y is a rotation from the outside of your mouth to the inside, so to your tongue. And the rotation around Z is a longitudinal rotation around the longitudinal axis of a tooth. And the most important thing about the Y rotation and about the Z rotation is the coupling between the two. So the value at every instance in time of a certain extraction. So for instance, in this figure, you can see the Y rotation in time plotted on as the green line, and the Z rotation plotted as the blue line. And if we can find a certain strategy at every instance in time where the dentist is moving, we can, in the end, make a feature out of this. So that is what I did. I defined a strategy bar, and the strategy bar is indicating what the current rotation, the coupled y and z rotation, is at every instance in time. So the first 15 seconds, you see that the strategy bar is annotated with a blue color, indicating that the strategy at the first 15 seconds is in the z direction. And then from 15 seconds onwards, you see a small blue bar, or a small green bar appearing, indicating that the strategy at that part is towards the y direction. And the last part is z direction. So we can extract, or we can make a feature, a numerical representation of this strategy. So what we can do, we can express the amount of z rotation as a percentage of the total time of an extraction. And that's what the feature z percentage represents, and the y percentage feature represents the total time the dentist is extracting in y direction as the total time of an extraction. And if we plot the z percentage versus the y percentage for all samples of the dentist, what we can see is that clear clusters are appearing. So the upper molars are mainly oriented to the bottom right of the plot, where almost no z rotation is performed and y rotation is performed. If we see the z, if we plot the upper incisors, we can see that the upper incisors are located to the upper left of the plot, where no y percentage is available, and we see that there is a high z percentage. And these are all the samples for the upper jaw. And if we plot the samples for the lower jaw, we see that the lower molars appear in this spot, and we see that the lower incisors and the lower premolars appear when almost no z percentage or almost no y percentage is available, and where z percentage is present. We see that the last cluster appearing has two groups, and that's because there are anatomical differences between the lower incisors and the lower premolars. So from these four clusters, we can make the 5 classes as shown in text. And based on this plot, we can argue that there are differences in strategy between these classes. And if we want to define and quantify what these strategies are, we can make heat maps. And that is what I want to show here. We see for the main surgeon that all extractions for the upper incisors are plotted as a heat map in the upper figure. And most interesting is that we can see that the rotation around z is very high, and the rotation around y is very narrow. If we compare that with the rotations of all the extractions from the lower molar group, we can see that the heat map is oriented around a 45-degree angle, indicating that the rotation around y and the rotation around z are simultaneously used as a strategy. So no clear z rotation or no clear y rotation is used, but some sort of a wiggle, which is a very different strategy from the upper incisors. If we compare what the student is doing, we see a total different plot appearing. And the student is just extracting in y and z all over the place, and no clear strategy can be deducted from this. And this is indicating that the student is doing something different. It does not indicate that the student is very bad, but it indicates that he has no clear strategy in mind how to extract a tooth. So, from the measure and the analysis phase, we as humans were able to see differences, and we use feature engineering for it. But we can also see how an automated machine in the form of a prediction model is able to highlight these differences as well. And to make sure we're all on the same page, I will tell something about supervised machine learning classification, which I used, and I will give a small introduction in the form of a spam filter. And everyone knows what a spam filter is. It translates the inbox from your emails, or it takes incoming emails and it divides it between an inbox folder and spam folder. And this classification algorithm is classifying in an inbox class and classifying in a spam folder class. And what it is doing, it is learning to do so. And how does this learning works? So we can make an analogy with a teacher teaching a topic during a semester. So if we have a teacher and he is telling a certain topic in lectures, and students are getting knowledge from this topic. And at the end of the semester, the teacher is testing the knowledge of the students with questions which are on the topic the teacher was teaching. And these questions are not seen by the student before, but these questions are covering the material taught during the semester. And the lectures are the training phase, and the test is the testing phase, and that works in machine learning as well. So machine learning or supervised classification algorithms have a learning phase and a testing phase. And this is needed to understand the following graph. What we can do, we can identify or experiment of an upper incisor in the upper incisor class, and we can identify our experiment of our upper molar in an upper molar class. And we can make a prediction model out of this, and we can train this prediction model to give a certain model, and this model should then be able to identify what the class is of a new unseen experiment, and he should predict what type of class it is. And we can see that this is an upper incisor, but we should make sure the model does as well. And this last part is called the testing phase. And this training and testing is also implemented when you train a prediction algorithm named a Gaussian Bayes. And what I want to show here is the unseen data of the main surgeon, which are 21 samples. And on the horizontal axis, you see the predictions made by the model I implemented, and on the vertical axis, you see the true labels in the form of classes. And I want to highlight that if all your samples are on this diagonal line, you have 100% prediction accuracy. So in this example, we see that the model predicted 2 samples wrong, which gave an accuracy of 90%. Furthermore, we can see that all these samples are 0, indicating that the model with the features of rotation and the feature of force are making predictions very accurately between upper and lower jaw. So no classification mistake between an upper jaw sample and a lower jaw sample is made, indicating that there are clear differences between extractions of an upper jaw and a lower jaw. And furthermore, I imported a SHEP feature importance model, which is highlighting the importance of the features of the model. And at the left, you can see the features in a decreasing order of importance, and the colored bars are the cumulative impact on the model's output. So what we can see is that the Z percentage and the Y percentage features are very descriptive and yield a high model accuracy. But the third most important feature is the Z complexity feature. And this Z complexity feature is a feature of force. So based on this graph, we can say that also force features are needed to gain high prediction accuracy in the model together with our rotation features. So what did we learn today from understanding tooth removal? We started with the research question: how can the process of tooth removal be understood in terms of forces, torques, and movements? We started to measure the tooth removal procedure with our measurement setup, and we measured in vitro measurements, and the obtained data we analyzed with feature engineering, and we saw that rotation features were very important to describe differences between strategies. And we also evaluated how these features performed in a prediction model, so how automated machines were able to find these patterns as well. So concluding, we started from 0 with understanding of tooth removal. Nothing was known yet, and we unraveled the black box of tooth removal little by little. And what was most interesting is that we were able to see what tooth removal strategies were present, and especially based on the rotation features, we could find differences between groups of teeth. And we could use the features of rotation, but also the features of force in a prediction model. So even with limited data, we can see that prediction model is able to highlight these differences as well. So there are certainly some limitations to this study, and the main limitation is that we don't know how our in vitro measurements, so on non-living organisms, are translating to clinic. So we don't know what the influence of the robot is, but we also don't know what the jaws, or how the jaws represent real jaws. And next to that, we still have a limited amount of data. We were able to show some nice prediction results, but still this is quite a limited data set. But if we want to continue this, and if I may make some recommendations for future work, I would investigate the features of force a little bit more, because currently these are not used well in the prediction algorithm, and they could be more descriptive. We can also use the current setup to evaluate preclinical education methods. So now the education methods are mainly based on plastic jaws, and we can evaluate how feasible these are, and later on we can improve these educational material. And at last, we can test the validity of our rotation features in a haptic simulator, which we maybe can use to guide students or to guide dentists in the far future. And this was our team, together with Jens and Tom. We had very nice days when measuring, and it was nice fun. So, are there any questions?
Questions? So either that was extremely clear or extremely confusing. I hope for the former. You can also type them in the chat on YouTube.
Yes.
Nope. Oh, first applause is coming in.
Okay. Yes, I will wait a second.
Okay, there's one question. Well done, brothers. Thank you for the clear presentation. I have a question on the prediction model. Because why do you use the Gaussian naive Bayes model and not another prediction model?
Who asked the question?
Maureen?
Oh, Marijn. Thank you for the question. I will go back to the naive Bayes model. What we saw is that, especially with limited data, and we had limited data, the data set was 68 samples, and of which 21 were a test set. And naive Bayes was good at prediction accuracy. I did not test it myself at the beginning, but along the process we saw that the Gaussian naive Bayes yielded the best performance for such a limited data set. A logistic regression model was implemented as well. I did not show that in the results, but this showed overall limited accuracy. And if you would implement a machine learning algorithm, for instance, or a neural network, for instance, you need very high amount of samples. And the naive Bayes is working naive, and in this way it yields high performance with limited data.
Just got a second question from Hokix.
Oh yeah.
Thank you for this very interesting presentation. What would you expect in terms of data shift when you acquire data from more surgeons?
A very interesting question. Thank you, Jorik. The aim is to ask the same surgeon, which if we would acquire more data, we would ask the same surgeon, and we would let him extract. because we included 3 surgeons, and we saw already that there are differences in extraction strategy between 3 surgeons. And in the end, we want a clear and consistent data set to start with and to explain further, because a clear data set from one person, you know most sure that this person is extracting and applying the same strategy every time, instead of different persons extracting different strategies. So the goal is to ask the same person for expanding our data set.
Any more questions online or here?
Do you have a question, Jens?
We still have an hour to ask plenty of that's the main questions.
Okay.
Yeah, then let's thank Willem again.
Okay.
Yeah, so we'll move on to the closed discussion that we're going to have about an hour to ask more detailed questions to Willem, and then we'll still need a couple of minutes to deliberate and give him some feedback in detail. So yeah, we'll be ready to hand out the diploma if nothing really unexpected happens around 3:45.
Yes. So for people in the live stream underneath, I will get back to you when the question hour is over, and then I will say that you can join in again.
Tell from the presentation, which we thought was extremely clear, and I hope also you could follow very well, is he did lots and lots of work, starting from helping us design the measurement setup, and actually being involved in collecting the data, and then pre-processing and processing, and starting from really just a very vague idea. Okay, we have this huge amount of data, and now we want to find something interesting in that, and we let it loose. And in the end, we now have some interesting insights on actually what this data represents. So yeah, we were really happy with that. Presentation was nice, reports very extensive and well written, and was really a pleasure to work with Willem. Sometimes we had the impression that he's so motivated that he loses a bit the sight left and right. It's just going straight ahead, and then we had to try to stop him a little bit from getting into a dead end. But yeah, that's not uncommon. But that went very well after all. So in the end, we decided to go with an 8.5 as a final grade. Okay. You also want to say a few words? And then we still have the official signing to do.
I've actually made a 2-minute PowerPoint.
Oh. No.
No, that's wrong.
Who is that?
Je moet op dat oogje drukken natuurlijk bij.
Steve, there's an N in my password and he doesn't.
Oh, that's to keep the suspense. Willem. Zo, de 37 MB. The road to becoming a master.
Okay, so Willem, this is your road. Oh, where does it go?
Oh, maybe he's on a different. On a different.
Open.
Wait.
Open. Oh, in tweede instantie.
A few slides.
Okay. So Willem, I just had a very quick PowerPoint set up because I wanted to show some photos. So your road to becoming a master was slightly different than probably most of your colleagues. That was because you had to deal with someone from a medical field. That's why there's a curve in the road. We first received an email from you 28th of May 2019, so it's almost exactly 1.5 years ago. You were in Singapore doing your ROS thing. I had no idea what ROS was. And you explained to us that you would like to be involved in our project as your master project. We spoke to you, I can still remember, over Skype. And we told you about the black box that you were about to face. There's nothing really known about tooth removal. If you talk to people about this problem, people are highly, how do you say it? They get nervous because they've been in a dental chair and they are scared, and now they're extra scared if you explain what you're going to do. So the moment you started, I was impressed by your approach to doing things. You're very extensive. So if you say to a master student, could you please show us roughly what you're about to do, and they come up with this PowerPoint with percentages and timelines and weeks and days. So that's a good sign to start off with. You started as a summer job together with the guys from the mechanical engineering department, who helped us to build this measurement setup. So this was an interesting phase. This was purely mechanics. And you had brainstorm sessions with me on what we're supposed to do, and it was more than once, maybe sometimes twice, or we had a lot of these very fuzzy meetings. But in the end, we came up with a setup, and a lot of people were interested. So there were more than one head of departments who actually walked up some stairs to visit your measurement setup. You came, you saw some old friends. And during your master, you had some field trips as well. This is at the operating theater in the AMC. He's wearing a gown and also a lead skirt to protect him from any radiation. But I think we both enjoyed it. You got to experience the very bad days of doctors at work in the massage chair. And you were also present at the technology conference to present our work with great enthusiasm. So these were very nice days. Then to actually get the thing working, we put the measurement setup in the hospital, so we needed to have our own little truck. We drove the robot to the Amsterdam University Medical Center. You're in the basement actually. And now things are getting exciting because now the robot's in the same room as a skeleton. And I still remember that at first this was kind of exciting also for you because we have 8 of these rooms. They look a little bit like this, so there's a lot going on. And there's also a few doors that do not open to everyone. There's a certain smell and there's a certain temperature. So this for an engineer is it's somewhere near your boundaries probably. And you can see here that it's cold. So Willem was always wearing his sweater and his coat. But there's also a big smile on your face, so that's good news. And a little bit of exercise got you through the day, I guess. So I just want to thank you very much for your hard work these last 18 months. I think you helped us very well with our ideas, and I think you really made it your own project, for which I'm very grateful. And hopefully you will be working with us a little bit longer, I hope. And I think you well deserved an excellent grade for your master thesis, so for which I would like to congratulate you. So congratulations.
Yes, thank you, Tom. Thank you. Shall we go further?
Do you also want to say something?
Yes, I prepared a little speech. So first, I would like to thank Tom and Jens for their enthusiasm, especially the nice meetings we had, where we Jens and I had to take a united front against Tom, where Tom was spending all his ideas, and Jens and I were just saying what was possible and what was not possible, and it was very interesting. And I learned a lot, and also I learned a lot about dentistry. And next to that, I want to thank my study friends who are watching on the live stream. They all the days we spent in the library studying, and then COVID came. Then we all had to sit at home. But I think we in Dutch we would say we hebben elkaar doorheen geslagen. Thank you for that. Also my roommates, which are very nice to me and always helped me when I had questions, how I had to approach stuff. And my friends from the town in Zwolle, where I could discuss my interesting things with them. Thank you for that. And last but not least, my parents and my brothers, who were very supportive and helped me. And of course, my girlfriend Marit. Thank you very much.
And let's get the official things done. It's a nice tradition that actually the whole committee signs, which is very exceptional with Corona nowadays.
Yeah.
But before we do that, can you just quickly check that your details are correct?
Kind of engineering.
Yeah.
Yes.
Yeah.
Only my 5 August to support Willem. Yes. Yeah.
Yes. Good.
Right.
Yeah. Well, first, all right.
Sure.
Where is the
On the left.
just the signature, right?
Yeah. And backside as well.
There's another opportunity. There you go.
So somewhere on the left side.
You might look.
Good. And now the big photo moment. But before we do that, you get your first present.
Oh, great.
And maybe test it first if it works.
Yeah, just try it on the
Yeah, on the paper.
the stick papier. Oh, there you go.
Ja, ik heb nog eentje.
Ik vind op het einde even stilhouden.
Ja?
So now it's official.
Yes.
Yes.
Yay!
Thank you.
Maybe we should have a photo with his
supervisor's just nicely behind him, and we on both other sides. No, you're in the middle. You're the most important guy here.
Yeah?
Yeah. You need you stand higher up?
Yeah.
Yeah, yes, go. Yes, we just wait for you. This is only once in a lifetime.
Yeah.
Thank you.
All right.
Good. And now we have a few more presents. You get a nice little red coca, whatever that is in English, to store the degree. And he gets a cute little robot, which is a USB stick
Oh, nice.
from the department. And then you get one final pin from the Alumni Association,
Also. Oh.
where I guess the hope that you're going to donate.
I hope so. Yes.
Yes.
Thank you. Yeah, I don't have anything to say furthermore. Thank you. Yeah, I should just roll it in, right? Oh yeah. Wat, mine?
En dat was echt. Ze gewoon niet leren.
To express my appreciation for my supervisors, I bought you a small bottle of wine.
Yes.
So one for you, Tom.
Surgeons always say we can't drink flowers. So thank you.
And one for you as an appreciation for the supervision during my period. Oh yeah. So thank you.
Cheers.